Okay, so let's look at an example that's not given in the book. It's one of the homework problems. All right, so it says the velocity function is given in feet per second for a particle that moves along a straight line. Find the displacement and the total distance of the particle over the given interval. Okay, so v of t is 5t minus 7, and you're going from 0 to 3. Okay, displacement is you just go from 0 to 3 and you take the integral of this. So if you're doing 5t minus 7, so the antiderivative of 5t would be 5t squared over 2. And the integral or antiderivative of negative 7 would be negative 7t, and you're going from 0 to 3. And then if you plug everything in and solve, you get 3 over 2. Okay, so since the answer is positive, that means that you are moving to the right. Okay, so that's just displacement. Okay, distance. Okay, so things you have to factor in with distance, okay, because you're going to have to do like the absolute value. So you're going to have to take into the fact that the negative stuff is actually going to become positive when we do our integral. So 5t minus 7, we're going to set it equal to 0 so I can figure out where is it crossing the x-axis, because I need to know what my interval is here to make this negative area actually end up being positive when I take the absolute value of it, okay? This is just a quick graph of what this looks like. You should all be able to graph this graph. So if you solve for t, okay, so you add 7 over, divide by 5, okay, so it's 7 over 5, which is 1.4, okay? So v of t is going to be less than or equal to 0 when you're in between 0 and 1.4, and it's greater than or equal to 0 when you're between 1.4 and 3, okay? All right, so we're going to do from 0 to 3 the absolute value of 5t minus 7 dt. Okay, so to take that into account, from 0 to 1.4, it's going to be negative. So we're going to end up having to make it positive because we're doing absolute values. So you're going to multiply this negative by this integral, okay? And then from 1.4 to 3, it already is positive, so we're just going to leave it alone. Okay, so if you take the antiderivative, and I went ahead and distributed the negative in there while I was working, so it's going to be negative 5 over 2 t squared, and then a negative times a negative makes it a plus 7t, and then take the antiderivative over here, and then if you evaluate it and you do 1.4 over here first, then subtract off 0, and then do 3, and then subtract off when you put in 1.4, you end up getting 11.3 feet, okay? So the total distance was 11.3 feet for this particle.